Okay, these are your notes for inequalities, how to write, graph, and find solutions. This is the beginning of stop 2. This is just stuff that you need to know before you can actually go through and do your pit stops. So we're taking these notes in class in case you missed it. All right, so for inequalities, inequality, in, equal, so not equal. Inequalities don't equal something, all right? But they could be greater than, less than, greater than or equal to, less than or equal to. So they could potentially end up equaling something, but it's also everything smaller than or greater than. So unequal means not exactly equal to. So here's our first symbol. This symbol is greater than. Okay, the greater than symbol, this is how you say it. Okay, this is how you graph greater than. All right, graphing on a number line, you would have an open circle. Okay, we call that an open circle because it's not colored in, it's wide open. Okay, an open circle because it doesn't include that number, and then everything greater than that on the number line. So here's an example. If I have x is greater than 4, let's draw us a number line here. 3, 4, 5, 6, and 7. I just made my own number line, okay? So I want everything that is greater than 4. Everything greater than 4. So that means that since it's 4 here, I'm going to put my circle on 4 because that's where I'm going to start. Okay, but it's an open circle because I want everything greater than 4. That doesn't include the number 4, so that's why it's an open circle. Okay, it does not include the number 4, but I want everything greater than that. So greater than that on the number line. We know as we go farther right on a number line, our numbers get bigger. Okay, and you can also notice that the arrow, okay, that you draw here, this arrow, should point the same direction as your inequality symbol. So greater than and this arrow on the end of your line both point the same direction, to the right. That's how you can check to make sure that you did that correctly. Okay, so x would be greater than 4, so that does not include the number 4, but it's everything bigger than that. So solution also means answer. So what are possible answers to this inequality? So what numbers could I plug in for x that would make this inequality true? Well, I need anything that would be greater than 4. So 5 is greater than 4. 6 is greater than 4. 7, 8, and that list could go on and on and on and on and on. All right. What about possible solutions that would not work? Okay, these were not solutions, so a number that I would put here that would make this not true. Well, what if I put a 4 here? Is 4 greater than 4? No, it's not. It's equal to it, so that doesn't work. Okay, I could put a 3. 3 greater than 4. 3 is not greater than 4, so that would not be a solution. 2, 1, and so on. Okay, so if you look at our possible solutions, the yeses, well, that was everything that fell on this line that we drew, 5, 6, 7, and that would keep going on and on. So if it's on the line that you drew, those are possible solutions. Notice that the ones that we put for no would be all these numbers over here on the number line if this kept going this way. Okay, and it kept going that way. The number line kept going. All these numbers were not part of the line that we drew, so that's why they are not solutions. Okay, so this is how to figure out possible solutions. You just take the number and plug it in and see if it makes the inequality true. Some keywords that will help you figure out what inequality symbol to use. So for greater than, keywords you're going to look for would be more than, greater than, larger than, above. Those all mean bigger or greater than. Second one, less than. If you notice this symbol less than, it kind of makes an L. Okay, it kind of looks like an L, a sideways L, like it's tilted. So less than kind of looks like an L. That's how I remember that this symbol is less than, because it kind of looks like an L that's just kind of like that. So this symbol is less than. If we were going to graph this symbol, it would be an open circle pointing to the left, because on a number line, the farther you go left, the smaller you get, okay? Or less than that number. So if I were going to graph x is less than 7, all right, x is less than 7. Let's go 4, 5, 6, 7, 8. Okay, I'm just making a number line. Now let's graph that. So x is less than 7. 7 is where my circle is going to go. It's an open circle because it does not include the number 7. I want everything less than 7, not equal to, but less than 7. So everything less than 7 or smaller than 7 is going to be this way on the number line. And remember, your arrow that you draw on the end of your graph should point the same direction as your inequality symbol. That's a way you can check yourself. So let's figure out possible solutions that would work for this graph or this inequality. So remember, everything that's yes is anything that I graphed on my line. So all the numbers less than 7. So 6, 5, 4, 3, and so on. But what would not be solutions, or what number could I put here to make this not true? Well, 7 wouldn't work because 7 is not less than 7. It's equal to it. 8 would not work because 8 is not less than 7. It's also not part of the graph that we drew. 9, 10, and so on. All these numbers, if I plug them in here, 8 is less than 7. That's not true. If I plugged a 9 in, 9 is less than 7. That's not true. 10 is less than 7. That's not true. So that's why these are all no's. Some keywords that you could look for to help you figure out that it's the less than symbol would be smaller than, less than, or below. Okay, this next one is greater than or equal to. So it could be greater than or equal to that number. Okay, to graph that, we use a closed circle. So we call this closed circle, and this is called an open circle. Okay, it's wide open. You can see right through it. This is closed because it's like you closed a door. You can't see through it. So a closed circle, that's how you graph greater than or equal to. So here's our inequality. X is greater than or equal to -3. So let's draw some numbers here. Okay, -4, -3, -2, -1, and 0. If I were going to graph this, I'm going to start at -3. Okay, that's where my circle goes. But it's x is greater than or equal to -3. So it could equal -3. So I'm going to close in that circle or color it in because it could equal -3. And I want everything greater than that. So greater than would be this way to the right on the number line. Remember, your arrow on the end of your line should match your inequality symbol. They should both point the same direction. So let's try and figure out possible solutions to this inequality. So what are numbers that I could put here that I would say, yes, that is true? Well, could I include the number 3? Is 3 greater than or equal to, -3. Is -3 greater than or equal to -3? Yes, -3 is equal to -3, so that works. What if I put a -2? Okay, notice it's on the graph. Is -2 greater than or equal to -3? Yes, it is. -1, 0, I could keep going. Okay, what about possible solutions or answers, numbers that I could put here where I would say, no, that is not true. Okay, so that would be maybe, let's start with -4. If I put a -4 here, is -4 greater than or equal to -3? No, it's not. Notice also it's not part of the graph. Okay, we graphed this dot and this line. That -4 is not a part of that. Okay, so -5, -6, -7, keep going. That could keep going forever. Anything over here on the number line. So that's how you graph greater than or equal to. Some key words to help you figure out that this is the symbol you need would be minimum. If I have a minimum of 10 seats, that means I have 10 or more seats. If the movie is going to charge me a minimum of $5, that would be 5 or more dollars. Okay, at least or no less than. Those are other words that would help us figure out that it's greater than or equal to. Okay, this one is less than. Remember, that kind of looks like an L. Less than or equal to. Okay, that would be a closed circle because it could equal that number, and everything less than that or to the left on the graph. Left, less, there's another trick for you. Okay, so I have x is less than or equal to 0. So let's create this number line from -2 to 2. All right, if I was going to graph this, I would put my circle on 0. And I want everything less than or equal to 0. So it could equal 0, so I'm going to close in my circle. And I want everything less than that. So remember, the arrow on your graph should match your inequality symbol. They should both point the same direction. All right. Now let's figure out solutions that would make this true, or I would say, yes, that does work. So what numbers could I put here to make this inequality true? Well, could I put a 0 there? Is 0 less than or equal to 0? Yes, it is. Okay, what about -1? Is -1 less than or equal to 0? Yes, it is. It's also on the graph. Okay, -2, -3, and that could keep going. All right, what are numbers that I could put here that I would say, no, that is not a solution to that? Okay, it's not true. Well, what about 1? Is 1 less than or equal to 0? No, it's not. Okay, 2, 3, 4, any of these numbers that would be over here on the number line. Notice they're not part of the graph we made. Okay, so any of the numbers over here on the number line, those would all be no. They are not less than or equal to 0. Okay, some key words would be maximum. Okay, if you think of maximum, the maximum amount of money that I can spend is $30. That means I can spend up to $30, but I cannot spend any more. Okay, or your maximum ceiling height is 9 feet. That means it can go up to 9 feet, but it can't go over that. Okay, or at most, no more than. Okay, and the last one we're going to look at is equal to, because although this is obviously not an inequality, because inequality means not equal, this is a graph. This is something that you need to know how to graph. So if something's equal to something, we just draw a closed circle on that number. So if I had the number line 3, 4, 5, 6, okay, and I wanted to graph x equals 5, well, I put my circle on 5, and it equals 5, so it is 5, so it's closed. Now I don't need to draw a line because it's just x equals 5. It is 5, so it's just a dot. Yes, answers to this problem. What is the only number I can put here to make this true? Well, 5. 5 equals 5. Yes, it does. That is the only number that equals 5. No would be any other number that is not 5. So you could do 3, 4, 7, 8, 10, endless amount of numbers that you could pick as long as it was not 5. Okay, and the only keyword you're going to look for there is equal to. So this is just some symbols and how to say it and how to graph it that we need to know before we go into solving one-step inequalities.